Picture this. You wake up to an alert that every single system in your production environment is locked down by ransomware. Total paralysis. Your first instinct? Probably to reach for your backups, right? But what if those backups are exactly what the attackers went after first? Well, welcome to this explainer. Today we're diving deep into a high-stakes survival manual based on AWS's latest architecture guidelines for cyber resilience. We're going to map out exactly how to build an AWS infrastructure that doesn't just withstand an attack, but actively empowers you to rebuild your entire digital civilization from a secure bunker when the absolute worst happens. So there's a pretty massive shift in mindset happening right now. For years, the IT industry has been completely obsessed with cybersecurity. That's your prevention and detection layer, the walls, the moats, the alarms, all designed to keep threat actors out. But this explainer, it isn't about that. We are focusing purely on cyber resilience. This is the hard acceptance that sometimes the walls actually fall, defenses fail. Cyber resilience is all about recovery. It's the exact critical set of actions you take to restore a trustworthy environment when your backups, your credentials, and your infrastructure can literally no longer be trusted. Okay, so here's our roadmap for survival today. First, when defenses fail. Second, the architecture of isolation. Third, the decontamination process. Fourth, the 5 recovery stages. And finally, rebuild, restore, rotate. Let's get into it.
Section 1. When defenses fail. Getting prepared for the worst.
Here's the crucial thing we have to understand about the modern adversary. In the past, ransomware was basically a smash-and-grab operation, right? They'd get in, encrypt your live data, demand some money, and get out. Today, data extortion and destructive events are meticulously planned. Threat actors actually know your recovery strategy. Before they ever trigger the ransomware in your production environment, they are actively hunting your recovery environments. They want to find your backups, delete them, or even just subtly corrupt them so that you have absolutely no choice but to pay the ransom. That literally changes everything about how we have to approach recovery.
Section 2. Architecture of isolation. Time to build our secure bunker.
The absolute core architectural idea in cyber resilience is isolation. Think about it. If your production identity is compromised, your recovery process cannot rely on it, period. To pull this off, AWS recommends splitting your infrastructure into 3 distinct account types within your AWS organization. First up, you have the production account. Think of this as the blast zone. It's where your day-to-day workloads run, and if an event happens, this account gets completely quarantined for investigation. Next is the recovery account. This account has literally one job: own and protect your backups. Finally, we have the isolated recovery environment, or the IRE. This right here is your clean room. It has zero trust with production, absolutely no VPC peering, and zero internet access. We only use VPC endpoints to reach AWS services inside the IRE. Why? Because if you accidentally restore infected data into this clean room, well, it has nowhere to spread. It's completely trapped.
Let's zoom in on that recovery account for a second. This is where you deploy the AWS Backup logically air-gapped vault. And honestly, this vault is incredible because it operates in what's called compliance mode. That means the service itself enforces retention. Literally no one, not even the account root user, and certainly not some compromised administrator, can delete those recovery points or shorten their retention period. It is 100% immutable. And to make it even more bulletproof, restoring from this vault requires multi-party approval, or MPA, configured through IAM Identity Center. So even if an attacker manages to steal a highly privileged account's credentials, they cannot independently authorize a restore or tamper with your survival data. No way.
Section 3. The decontamination process. Ensuring our backups are actually safe.
I really want you to pause and think about this question for a second. What if your most recent backup is already infected? In normal day-to-day operations, like, say, a developer accidentally drops a database table, you just grab the most recent backup and hit restore. Super simple, right? But in a cyber event, doing that could be catastrophic. If a smart adversary was lurking in your systems for weeks before pulling the trigger, your last 20 backups might carry the exact same malware or compromised code that caused the disaster in the first place. So blindly restoring the latest block of data, you might just be resurrecting the threat actor right inside your brand new environment.
And that scary thought brings us to the validation pipeline. You see, a successful restore operation only tells you that a backup is readable. Validation is what proves it's actually safe to use. And there's no single magic button you can press here. It requires multiple layers of checks. Inside your isolated recovery environment, you pass backups through this decontamination pipeline. You might start off with AWS Guard Duty malware protection to scan restored volumes for known ransomware tools. But, that's not enough for sneaky, long-term compromises. So you pair that scan with workload-specific integrity checks. You're looking for database consistency errors, application invariants being violated, or weird configuration diffs compared to a known good baseline. You're also actively reviewing CloudTrail and workload logs across the backup window. Only when a backup passes all of these strict tests is it finally declared clean.
So how exactly do we find that clean copy? Well, we have to travel back in time. First, you establish an event boundary, basically the earliest plausible indicator the attacker was inside your system. Then, you evaluate recovery points in reverse chronological order. Say you pull the first candidate from 2 hours before the event. Let's say it fails, the scanner spots an anomaly. You immediately discard it. Step back to 4 hours. It fails too. Step back to 6 hours. And finally, this one passes the malware scans and the workload consistency checks. Boom. This is the candidate that gets approved for recovery.
Section 4. The 5 recovery stages. Putting the battle plan into action.
Now, you might look at these 5 stages and think they happen sequentially, one right after another. Actually, scratch that, they don't. When a business is down, every single second costs serious money. Because of that, stages 1, 2, and 4 run entirely in parallel. It's a frantic race against the clock. While the security team is frantically querying logs to establish the timeline in stage 1, the recovery team is already validating older backup candidates in stage 2, and the cloud engineers are busy rebuilding the clean infrastructure over in the IRE in stage 4. They're all racing towards stage 3, the approval gate. We wait at this gate because we absolutely never restore untrusted data into our freshly built environment. Only once a backup is formally approved at stage 3 does the data actually flow into the rebuilt infrastructure.
Finally, we reach stage 5, cutover. You've completely rebuilt the environment and restored the validated data. But you don't just flip some massive switch. You carefully shift production traffic using DNS records with health checks, making sure the new environment is fully ready to take on the load. And this is absolutely crucial. You leave the old, compromised production account completely isolated so the forensic investigation can continue without interference. Oh, and don't forget the plumbing. You have to update all those cross-account references, like IAM role trust policies and KMS key grants, so they point to your shiny new environment and not the old infected one.
Section 5. Rebuild, restore, rotate. Piecing it all back together.
This single quote from the AWS Architecture blog dictates the entire foundational framework for piecing your digital civilization back together. It goes, infrastructure is code, data is backup, credentials are new. Keep that in your head.
Let's break that framework down piece by piece. First up, rebuild. You never, ever restore your infrastructure configurations like your IAM policies, security groups, or VPCs from a backup. Why? Well, because the attacker might have subtly modified them to leave a backdoor. Instead, you rebuild these entirely from clean version-controlled infrastructure as code templates. Second, restore. You obviously can't code your business data. Your customer records, your financial transactions, all of this must come from those immutable validated backups we locked away in the vault. This applies to things like EBS volumes, S3 buckets, and Aurora databases. And third, rotate. Any secret that existed during the attack window must automatically be considered compromised. You do not bring old passwords into the clean room. Access keys, database passwords, OAuth tokens, the whole shebang must be generated completely fresh.
All right, so we've covered the blast zones, the air-gapped vaults, the decontamination pipelines, and that essential rebuild, restore, rotate framework. But as we wrap up, I want to leave you with this final, somewhat provocative thought to take back to your own teams today. Take a hard look at your current architecture. Look at exactly where your backups live right now. Are your backups a true isolated lifeline? Or in the eyes of a modern threat actor, are they just another target waiting to be encrypted? Thank you so much for joining me on this explainer. Until next time, keep learning, keep building, and for sure, stay resilient.